That's where, by the way, we're gonna leave out 11 today. Yeah. It's like 11:05. Yeah. Watch me sit on the left of it. Yeah. Right. I'm not your coach, I'm right. Yeah. I like it. Just read the scores like. Yeah.
About how much?
If you don't break 80,
Birthday, my birthday.
you count the days.
Yeah, because I, Brad, remember that, well, I think Brad, so my first year,
Okay, so I'll take a couple LTA 8 questions if we have them now.
probably won't have.
Okay. Number 18.
Number 18. Okay, so this is where we have to finagle our laws they gave us in chapter 5. So they want sine in terms of only secant. So if we start off with, let's see, we started off with, what's our secant squared equal? That's the one you want to get back to sine. So this would be the same as, we could flip these two, right? We've talked about this before, or if this is equal to this fraction here, I can flip this with the denominator, right? Because I can multiply both sides by cosine and then divide by secant. So I could switch these. So I get my so far so good? And then we know cosine squared t because we knew this other rule, right? We knew this other rule. So then if I solve for cosine squared t, so plug that in for cosine squared t. And move the 1 over. So we have it in terms of, we have sine in terms of only secant. So if you know secant, you can get sine in this. Cool. Any other questions? 13. Draw on the graph. Okay, we got cotangent. I think these ones were the ones that we felt were the hardest. We had the biggest problem with tangents and cotangents. Oh, well, theta is your x. Yeah, a lot of the times, yeah. So it's just theta instead of x. That's your angle here. But still, our amplitude in cotangent, just 1, right? There's nothing in front. Okay, our period. It's going to be pi over k. In this case, k is pi over 8. So that's the same as pi times. So we should have just got 8. Yes, you're allowed to cancel. And then no vertical shift, no horizontal shift, so our count is just 8 over 4. 2. So, we go to start. Start drawing our cotangent graph. Remember, our typical cotangent graph didn't start, remember, tangent starts at the origin, so cotangent starts at the second interval, right? It's got vertical at the last and on the y-axis, and it goes the opposite way of the tangent graph. So, we have pretty much a typical cotangent graph here, except we're counting by 2. We don't have like our pi over 4, our pi over 8, so we're just going to count by 2. So first interval, 2, 4, 6, 8, and vertical asymptotes on the y-axis and our last interval. Starts at the second interval, and then our amplitude is 1 and -1. So we know first interval, we're going to reach our amplitude. Third interval, we're going to reach our amplitude. But that was basically because of the theta, we had a problem with that. Right, didn't have an x.
The theta and x are the same thing.
Right.
What's the period for? I feel like it's like irrelevant to the graph.
No, the period. Period is very important to the graph. That means I complete one tangent graph in 8 units. Started at 0, went to 8. So before, our period was like 2 pi. So even if you started, like maybe sometimes we started at -pi over 4. So that means you're still going to have to go 2 pi. So your period is going to take 2 pi distance. So the period is important. Any other questions from 8 before we go over the notes from Friday? Number 2. So find 2 values of theta in degrees and in radians. So we have to have 2 values of theta in degrees between 0 and 360, so positive values, and same with our radians. So, what is secant equal to? 1 over, right. So secant, 1 over cosine. So what angle gives you, well, let's see, how about that? Let's make sure we have the angle in terms of cosine. So that means this is, so then if I want just cosine, so what angle of theta gives you the exact value radical 2 over 2? Pi over 4. So already we have 1 radian value between 0 and 2 pi. Right, so we've got pi over 4. Now, it's positive, so what other quadrant is cosine positive in? Remember, cosine corresponds to the x value, so what other quadrant is the x value going to be positive? The fourth. Right? We have my quadrants. Right? X value is going to be positive if we go to the right, so cosine is going to be positive in the first and the fourth. So, if we're counting by pi over 4s, right, we got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 gets us back to pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, that's still going to be less than 2 pi, right, because 8 pi over 4 would give us 2 pi. So this angle here is going to give us radical 2 over 2, and it's still going to be positive because our cosine is positive in the fourth quadrant. And that was 7 pi over 4. Then they just want it also in degrees. Remember, pi equals 180 degrees, so pi over 4 is 45 degrees. And then 7 pi over 4 is going to be 315 degrees. And today's notes are going to talk even more about going from radians to degrees and from degrees back to radians. Does that help with number 2? I'll do one more if we got one more.
Number 20.
Is that another one of those switching?
No. It's asking about,
Oh, is that the vibrating tuning fork?
yeah.
That one? Okay, so we struck a tuning fork, and the vibrations are modeled by that function. So it's going to be sine graph, right? Let's see. First, I want to find the period. Okay, so our period. So we'll start just as we normally do. Amplitudes, 0.0, 0.7. Period. Sine graph, 2 pi over k. My k in this case just happens to be a little bit crazy, but that's all right, no big deal. 2 pi over 880 pi. So when I do 2 pi over 880 pi, I get 1 over 440. So that's my period. I take it that wasn't where we had trouble. Okay? So the frequency, the number of times the fork vibrates per second. Okay, well if it vibrates, if it completes one period in 1 over 440 seconds, how many times is it going to vibrate in 1 second? 440. So that tuning fork is vibrating 440 times in 1 second. So that's the frequency here. Right, because it completes one period in 1 over 440 seconds, but 1 second would give us 440 vibrations. So this was 1 over 440. And then the last one, just graph. Well, we got our count. 1 over 440 divided by 4. 1 over 1760?
Yeah.
And then what we freaked out is the fraction.
Yeah.
Okay. So we got our sine graph. Remember that our typical sine graph starts at the origin, reaches its maximum height at the first amplitude, reaches the x-axis again, not the first amplitude, at the first interval, reaches the x-axis again, second interval, minimum amplitude at the third interval, completes its period at the last interval, back at the x-axis. So in this case, our amplitude is 0.7. And we have a sine graph. It hasn't been vertically shifted or horizontally shifted. So it's just going to start at the origin. My first interval is 1 over 1760. So my second interval is 2 over 1760. My third interval is 3 over 1760. And my fourth interval is 4 over 1760. Then just draw our sine graph. So we know it reaches the maximum amplitude at the first interval, comes back down to the x-axis at the second interval, reaches the minimum amplitude at the third interval, then completes its period at the last interval. And, so what does the period matter? So if I did 4 divided by 1760, that's going to reduce down to 1 over 440. So again, we've completed our period in 1 over 440, Megan. That's where the period's important. So 4 over 1760 will reduce down to this. Cool? A little more comfortable with these trig graphs now?
So we're done with that stupid circle?
No.
No. We got one more chapter of that stupid circle. I thought this was easy.
I agree with the name.
It's just, once you know the base graphs, it's just shifting left and right and up and down. Just in radians instead of, you know, degrees, numbers like you guys are used to. All right. Then let's go over some of the examples from the notes on Friday. So they've given us a radian measure, or no, they want the radian measure of this degree. So to go from degrees to radians, you take your angle measure and you multiply it by pi over 180. Because remember, pi equals 180. So basically we're just multiplying by 1. But we're turning it into radian measure. So 200 pi over 180, that's going to simplify to 220 goes into both of them. Whoop. 20 goes into both of them, and reduce to 10 pi over 9. This is your radian measure of 200 degrees. That's it. So if you wanted to check that, you could do 10 times pi, which is 180, divided by 9. That should give you 200. So if you wanted to check your radian degree, you get this, you do 10 times 180 divided by 9, you'll get 200 degrees. Easy enough? That part's easy. Okay. One of them that wasn't on our notes, but someone brought it to my attention. What if I say I gave you, well actually let's see, they got to give you radians. So when we go from degrees to radians, then I'll go back to that. So now they want the degree measure. It's currently in radians. So to go from radians back to degrees, we just take our radian measure and we multiply it by 180 over pi. So just the other way around. So our pi's cancel. 180 and 2 reduce to just 90. So then negative 7 times 90 should have been negative 630 degrees. Cool. So now let's go back. What if I had like, I don't know, 2.1 radians? So I don't have a pi. Crazy. So 2.1 radians. Still want to go from radians to degrees. So I'm going to do 2.1 times 180 over pi. So 2.1 times 180. What does that give us? Someone with a calculator. 378 divided by pi. So what is 378? It's not 3.78. 378 divided by pi. It's going to give us the decimal, which is fine. 3.2.
Yeah, it's 32, then 1.
Alright. So that is my degree measure. So 1.2 radians is about 120.32 degrees. Good. That makes sense, right? Because pi 3.14 would be all the way back to my x-axis, so it's not quite 3. So it's going to be right there, about 120 degrees, if you guys like visualizing degrees instead of radians. So find two positive angles and two negative angles that are coterminal with this given angle. So right now, this angle, 135 degrees. Remember, if I got back to my x-axis, that'd be 180 degrees. So 135 degrees about here. What would my reference number be, my reference angle be? 45 degrees? To get us back to 180? Okay. So it wants coterminal. What do I mean by coterminal? One that's right there with it. Right, they end at the same spot. So 135 degrees, I have to find another angle. I want a positive, right? I want a positive angle and I want a negative angle that ends in the same position. That ends right here in the second quadrant with a reference angle of 45 degrees. So I could, to get another positive one, start there, and then add 360 degrees. Right, so if I just start at that angle, and then add another circle to it, just go around one more time, I'm still going to be at the same spot. Right, I'm just going to have more degrees because I've gone around the circle once, and then a little bit more. So to get another positive one, I have 135 degrees plus 360 degrees, because I want to go all the way around the circle again. And that gives me 495. That's the positive. You could have added 720 degrees, right? Go around the circle twice, end at the same spot. I would just do. Wait, it wants two positive. So yeah, let's do 720 again. Or another 360. So 495 would end the same spot, and then add another 360. Where are we at now? 855. So 495, 855, 135, all the same angle. All ending in the same reference. Okay, then they also want two negative angles. So negative angle means I start at my typical 1, 0, and I just go clockwise to get to my ending angle. So I could do 135 minus 360 because it's the other part of our circle. Right, so I could find the negative angle going that way. Or if you know that this is negative 180, right? And then plus 45. So I could do negative 225. Whatever you want to do. So if you wanted to do 135 minus 360, that's still going to give me my negative 225 degrees. And then I have to have another negative angle, so I'll subtract 360 degrees more. And what does that give? Negative 585. I would know how to do that for the next quiz. I don't know when that is.
Okay. Looking at how far into the semester we are and how many chapters we have left, how many more tests do you think we're gonna have?
At most 3.
We got a month and a half to graduation. Oh, we got us a couple tests.
Oh, we got this, but the other ones will only be like week-long chapters because we don't go into as much detail. 6 is like the last full chapter of the book.
When are you leaving for 7?
Am I leaving? Oh, for 7, May 10th. Something like that.
We leaving for 7 days?
No, chapter 7. You guys are going to do chapter 7 on your own. You can,
So that means we're not getting tested on that chapter, right?
no.
Open
It's gonna be like a take-home test.
Oh, I can do that.
Careful what you ask for. Okay, and so that gave us positive and negative. Cool. And last one. Now they've just given it to us in radian degree, and they want us to have 2 positive, 2 negative. Or no, it just says, oh, you just gotta find one of each. Find an angle, oh, they just want it to be positive, I got it. So our coterminal with that given angle, let's find that given angle first. I like to draw it out. So negative 7 pi over 3. Well, remember if I go negative pi over 3, that's 60 degrees. Negative 2 pi over 3, that's 120 degrees. Negative 3 pi over 3 would get us back to just 1 pi. And negative 4 pi over 3, negative 5 pi over 3, negative 6 pi over 3 would get us all the way back around. That'd be negative 2 pi. And then negative 7 pi over 3 gets us down to about here. With a reference angle of pi over 3. Okay. So that means that angle could also be written as negative pi over 3. And that would just mean I started at my 1, 0 and I went negative pi over 3 down, still giving us a reference number of pi over 3, right? Because our reference numbers are always positive. It just wants a positive angle. So between 0 and 2 pi. So it wants you to go this way around and tell me what that angle is.
So higher.
Nope. Pi over 3 would be up here.
Oh, it's right there at the bottom.
This is our reference angle of pi over 3. Right, but this angle is actually negative pi over 3 because I started at my x-axis and I went clockwise.
So what are you asking for? 7 pi?
I gotta find the positive angle.
Isn't that like
You gotta go over.
7 pi over 3?
Yes, that's the thing up there.
No, 5 pi over 3. It's gotta be a little bit less than 2 pi.
Sounds good.
Right, so if I went 6 pi over 3, I'd be back where I started. So you could do negative pi over 3 plus 2 pi. That's the same as negative pi over 3 plus 6 pi over 3. Right, 2 pi, 6 pi over 3. That's just going to be that gave us a value between 0 and 2 pi. That is coterminal, ending at the same point. Right, so just to re-emphasize it, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3 is going to give us that same angle. Right, yep. To make it positive.